So let's start with what is integration. Integration is the inverse of differentiation. In other words, it's the process of reversing differentiation or doing the opposite. So to go from y to dy dx, we differentiate. And then to go back to y from dy dx, we integrate. Here's the general rule for integration. This symbol here is called the integral symbol. And it's basically an instruction to integrate the expression next to it. The dx part means with respect to x. And that just means x is the variable that you're integrating. When you integrate x to the power of n, the rule is you have to add 1 to the power and then divide by the new power. You then also need to make sure you have a plus c on the end, and that plus c is called the constant of integration. As a basic example, let's try to integrate x to the power of 4 with respect to x. According to the rule, we'll need to add 1 to the power, so make it x to the power of 5, and then divide by the new power 5 plus c. Now that constant of integration plus c is really important to put on the end. If you forget it in an exam question, you will lose a mark. Let's have a look at why plus c is needed. Imagine you had two different equations, so y equals x to the power of 5 over 5 plus 3, let's say, and also y equals x to the power of 5 over 5 minus 7. If you were to differentiate both of these, in both cases, you'll get dy dx is 5x to the power of 4 over 5. You bring the power down and then reduce the power by 1. That then simplifies to x to the power of 4. And in the other equation, if you differentiate it, you'll get the exact same thing. Now remember, integration is the inverse operation to differentiation. So when we're integrating x to the power of 4, we need to put the plus c there because there could be a constant that disappears when you differentiate. And we don't know what that constant is. It could be 3, minus 7, or anything else, but we need to put the plus c there as a placeholder to recognize that. So in summary, we need a plus c because there could be a constant which disappears when you differentiate. Now let's talk about indefinite versus definite integrals. An indefinite integral would look something like this: integral of x squared dx. And for this one, we can just apply the rule that we saw earlier. So we're going to add 1 to the power, divide by the new power, and stick a plus c on the end. In contrast, a definite integral would look something like this. So you still have the integral symbol, but we have the addition of these little numbers here called limits. If we integrate x squared with respect to x with the limits 1 and 2, what that looks like is this. So you still apply the integration rule, add 1 to the power, divide by the new power, but you then put that inside big square brackets and you stick the little limits 1 and 2 there. We then need to evaluate the limits. So what we do is we create big round brackets like this. And inside each one, we're going to substitute in the limits into the expression. So for the first bracket, I'm going to take the 2 and substitute it in for x. And then I'm going to subtract the second bracket where I will substitute in the 1. So I've taken the limits and I've substituted them in here and here. You can then evaluate what's inside each of those brackets. So 2 cubed over 3 is 8 over 3 minus 1 over 3, which gives 7 over 3 overall. You'll see applications of this later on in the course, but this is how you evaluate a definite integral with limits. Now it's worth bearing in mind you only need to put plus c if you have an indefinite integral. You don't need the plus c for a definite integral. Now we've seen the basics of integration, let's work through some examples. Example 1. Y equals 4 root x plus 1 over x squared plus 10. Find the integral of y with respect to x. So first thing I do is rewrite the y expression to make it easier to integrate. This is the same first step if you're going to differentiate as well, by the way. So y equals 4 and then x to the power of a half instead of root x plus x to the power of minus 2 instead of 1 over x squared plus 10. Now we're ready to integrate. So term by term, first one is going to be 4x to the power of 3 over 2 divided by 3 over 2. Add 1 to the power, divide by the new power, plus x to the power of minus 1 divided by minus 1, plus 10x. And this is because a 10 on its own as a constant there is like having 10 next to an invisible x to the power of 0. So if we're going to add 1 to the power and then divide by the new power, we would just have x to the power of 1 or x. And then because this is an indefinite integral with no limits, we really need to put plus c on the end. We can then tidy this up using our calculator, for example, to do 4 divided by 3 over 2. And you'll get 8 over 3, x to the power of 3 over 2, minus x to the power of minus 1, plus 10x plus c. And that's it. Example 2, f dash of x is equal to 6x squared minus 3x plus 8. Given that the point 1, 8 lies on y equals f of x, find an expression for f of x. Now don't forget, f dash of x is just an alternative notation for the derivative. In other words, it's another way of writing dy dx when you have the y expressed as a function, f of x. But because we're given the derivative and we want to work backwards to find the original function, that means we need to integrate. Because integration, once again, is the reverse process of differentiation. So let's integrate. Integral of 6x squared minus 3x plus 8 with respect to x means we're going to get f of x is equal to 6x cubed over 3 minus 3x squared over 2 plus 8x plus c. We can tidy up a bit here. So that will be 2x cubed minus 3 over 2 x squared plus 8x plus c. And then don't forget we're given some information in the form of a coordinate that lies on the curve. So we can substitute this information in to find out what c is. So when x is 1, we're told that y, which is the same as f of x, is equal to 8. Therefore, if we substitute those numbers in, we'll get 8 equals 2 times this minus 3 over 2 times this plus this. We can then simplify and rearrange to find out what c is. Turns out to be -1/2. Therefore, you can put everything together for your final answer and say f of x is equal to 2x cubed minus 3 over 2x squared plus 8x minus 1/2. And we're finished. Last example, and we have a definite integral here. Find the integral of x plus 4 times x minus 3 with respect to x with the limits 1 and 3. So what I would do first is expand those brackets. X squared minus 3x plus 4x minus 12. Simplify x squared plus x minus 12. And then go ahead and integrate. So remember, with definite integrals, when you are integrating, you want to use big square brackets at this point. Stick your limits on the side on the right there. Do your integration. So in this case, x to the power of 3 over 3 plus x squared over 2 minus 12x. And then carefully substitute your limits in. I usually start by drawing the big brackets with the negative symbol or minus symbol in between them. And then I substitute in the numbers. So in the first bracket, we're going to have 3 cubed over 3 plus 3 squared over 2 minus 12 times 3. And in the second bracket, we're going to have the same expression, but with 1 substituted in instead. And then it's probably best to evaluate each bracket separately. In the calculator is fine. So in the first bracket, when you type that in, you get minus 45 over 2. You then have a minus, and then the second bracket comes out as minus 67 over 6. You can then evaluate this, and you get minus 34 over 3 altogether. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.